everyone, welcome back to another video. In today's video, I'm going to be talking about what is a chemical bond and what are the different types of chemical bonds. So let's begin. Well, the first and the most inevitable question according to me is that what is a chemical bond? Okay, so as a student of class 11th chemistry, I would just picturize a chemical bond as some solid interaction, okay, a solid joining kind of entity which is joining the two different atoms together, and that is what a bond according to me should be like. Okay, but that is not true. A chemical bond is not a solid entity. Okay, it is not something which is solid and which is joining the two atoms together. It is just an interaction, okay, an attractive of course interaction which is holding a molecule together. Okay, we all know how atoms combine to form molecules, right? So how are these molecules held together? With the help of attractive interactions which are called chemical bonds, right? So we might represent a hydrogen molecule like this, okay, where we just represent a small line in between the two hydrogen atoms, but this line actually is not a solid line, okay? This line actually represents an interaction between the two hydrogen atoms, and that is what a chemical bond is. The second most inevitable question according to me is that why do atoms even combine? Okay, so we know how atoms combine to form molecules, and that is okay, but why are they even doing that? Okay, why can't just they stay as like they are? So the reasons, if you ask this question to a pool of people, this is what you will get. The first one is to complete its octet, which means 8 electrons in its outermost shell. Okay. The second one is to complete its duplet, which is 2 electrons in the outermost shell, and the third one is for atoms to become molecules. Well, all this is not wrong. Okay, all this is true. But it's not the reasons why atoms combine, okay? The reason as to why atoms combine to form molecule is one, which is energy, okay? Energy is something which is controlling everything, starting from you, me, to the different atoms also. Well, everybody wants to be in a lower energy state. Even we also want to be stable in lives, okay? Settled in lives. The same thing is with the atoms. Atoms do not want to be at a state of high energies or excited states. No. The atoms want to be at lower energy states or stable states, and that is what happens to them when they combine to form molecules. Okay, so when any kind of bond is formed, it results in lower energy system or lower overall energy of the system, and that is why atoms combine to form molecules. Okay, now we know how energy is a conserved thing. Okay, it is not something which can be created, or it's not something which can be destroyed, right? So if we are saying that atoms are losing their energy when they are forming bonds, where is this lost energy going? This lost energy is going nowhere but in the environment, and that is why whenever a bond is formed, it is also accompanied by evolution of some kind of energy which is in form of heat or light, and that is why whatever bond it's ionic, covalent, it's always an exothermic reaction. Now let's talk about what are the different types of chemical bonds, okay? So before doing that, we should know how our periodic table is consisting of 3 different kinds of elements. We have metals, non-metals and metalloids. The metals are highly electropositive, okay? On the left hand side, we have all the metals which are highly electropositive, which means they want to give away their electron, okay, and become positive, electropositive, right? Whereas non-metals are highly electronegative, which means they are ready to take up electrons and become electronegative, okay? That's what your non-metals are. This would be a better image to understand it, because as we go from left to right in periodic table, from metals to non-metals, the size is going to get reduced, okay, and the electronegativity is increasing. The non-metals are highly electronegative and metals are highly electropositive, okay. So what happens in an ionic bond? Ionic bond is a bond between a metal and a non-metal, okay. So metals want to give away its electron and non-metals want to take up electrons. I think that's a match made in heaven, because that is exactly what happens in your ionic bonds. In case of your ionic bonds, as you can see on your screen, there's an example. Sodium is having 1 electron in its valence shell, and it is giving out its 1 electron to the fluorine atom and becoming fluoride. Okay, so we have this molecule which is sodium fluoride, which is an ionic bond. Okay, so here we have complete transfer of electrons, a total give and take of electron which is going to take place, and this kind of ionic bond is also called an electrovalent bond. Okay, so because of complete transfer of electrons, we have cations and anions. We have total ions which are formed. We have a positive ion, we have a negative ion which is formed. Okay, the one which is giving away its electron is becoming positive, which is cation, and the one which is taking up is becoming negative, which is an anion. Okay, and this is also called an electrovalent bond. Now let's see what is happening in a covalent bond. Okay, so a covalent bond is a bond which is formed between a non-metal and a non-metal, right? So there's no taking up and giving up electrons. In this case, we have sharing of electrons, right? So the electron pair is shared between the two combining atoms together, and the electron pair which is shared is coming one from each atom, and that's why we have a equal sharing of electrons between the two participating atoms, right? So we have sharing here. And the second thing is there are no ions which are formed. Just like in case of your ionic bonds, we have total cations and anions which are formed there, but that is not the case here. But polarity may exist. So we'll see what polarity is in a while. And shared electrons must belong to both the atoms, okay? Now moving on, we have covalent bonds. So before discussing about what is polarity, we should know what is electronegativity, right? So electronegativity is nothing but a tendency, okay, of an atom to attract the shared pair towards itself. So we know how your shared pair is being is a part of both the combining atoms, right? And it should be there exactly in between both the atoms, shared by both of them equally, right? But because of higher electronegativity, some atoms may attract it more towards themselves, and that is the tendency of electronegativity. In this case, you can see fluorine is highly electronegativity, having the value of 4. These values are on Pauling scale, okay, and you must remember these because they are quite handy. And lithium, as you can see, is having least electronegativity, right? So if I take an example of carbon and oxygen, okay, if I just make a covalent bond between these two, I would expect the shared pair to lie exactly in between carbon and oxygen, right? Because it's a shared pair. But it's not true. Because of higher electronegativity of oxygen, the shared pair is more towards oxygen, okay? And because of this shared pair shifting more towards oxygen, because of high electronegativity of oxygen, there is kind of polarity which is created, poles, positive and negative poles which are created. Remember, these are not charges, okay? Just like cations and anions, no. These are poles, and that is called a polar covalent bonds. A delta positive and delta negative charge is created, okay? A delta negative on the one which is more electronegative, which is oxygen in this case, and delta positive, which is carbon in this case. Whereas in case of other different atoms, like in case of chlorine, we would expect in a covalent bond the shared pair to be exactly in between, okay? And also in case of other different covalent bonds like C and H, where the difference is not very high, okay? Again, we would expect the shared pair to be exactly in between. That is called a non-polar covalent bond. So just to sum it apart, we have ions which are formed in case of your ionic bond, we have polarity in polar covalent bond, and we have completely non-polar system in case of your non-polar covalent bond. Now let's know what is a coordinate bond, okay? So a coordinate bond is exactly same as what you called a covalent bond, because here also we have a sharing of electrons between two atoms, right? But the difference is that in covalent bond, we have the shared pair which is denoted by one from each atom, right? Whereas in this case, the shared pair of electrons, both the electrons are donated by one atom, okay, and it is shared between the two different atoms, right? The one which is donating is called the donor, of course, and the one which is accepting is called the acceptor. So as an example, we have a molecule of ammonia, where we know that ammonia molecule has a single lone pair of electron which is free, okay, which is localized on the nitrogen atom, and here we have a hydrogen proton, okay? A hydrogen proton, as you all know, does not have any electron. Now, this lone pair is donated from the ammonia molecule to the hydrogen proton, and this adduct is formed, okay? Of course, ammonia in this case is the donor, and proton is in this case is the acceptor. Let us finally talk about what is a metallic bond, okay? So a metallic bond is a bond between different metal atoms, right? Now we already know how metals are very much electropositive in nature, which means they would definitely want to convert into electropositive form and then exist, right? Giving out its electron is something they just love to do, right? So they exist in this form where they give out their electron and they exist. The positive charges exist in a pool of electron, right? So one would expect all the positive charges to repel each other, right? Because positive should repel. But they are actually attractive because we have a pool of electrons, and that is called a metallic bond, which is again an electrovalent bond because positive metal kernel is attracted by the electrons around it. So that is what a metallic bond is, okay? So now, as a part of this video, we have discussed what are chemical bonds, why are they even formed, what is ionic bond, what is a covalent bond. In covalent bond, we have discussed the polar and non-polar covalent bonds. We have discussed what are coordinate bonds and the metallic bonds, right? So if we have any types of doubts in this video, you can just comment that down below and I will definitely try to answer. For more videos like this, keep watching. Stay tuned for more.